As an example of this whole process of formulating hypothesis and testing hypothesis, let me cite the example of our quest to understand the origin of the solar system. So, we are talking about the origin of the solar system. The origin of the solar system, this question itself did not occur to people's mind, so long as people believed that the whole thing has been created by somebody at some point of time. So, nobody really questioned that for a long time. Through the Middle Ages, nobody asked what can be the origin of the solar system. Only after Newton showed that the motion of the planets that can be predicted by humans, we can understand using natural laws. Only after that people started, only after the advent of mechanical materialism, people started worrying about the question of origin of the solar system. So, when this quest started, I said that first thing one does is to find out what are the clues. Clues means regarding the thing in question, in this case the solar system. What were the initial clues? The first clues was, so the first let us talk about the clues. First clue was that the solar system, all the planets move in elliptical orbits with the sun at a focus. That is the Kepler's law. So, the first one was the Kepler's laws. Second was that in a system where you have the sun at the center and the planets going in elliptical orbits, you can conceive various different planes of the orbits, one like this, another like that, and a third like this, and so on and so forth. But that is not actually true. We find that all the planets move in the same plane, they are coplanar. How do we know that? Simple. If you look at the sky at any evening, on any evening, and try to locate the planets, and if you do that night after night, you will find that all the planets are moving in a particular strip, a strip that is also shared by the motion of the sun and the moon. So, which means that everything is in a particular plane, and that is called the zodiacal strip. And why does that happen? That happens because the solar system is coplanar. The solar system is coplanar. So, it is like here is the sun, one is moving like this, another is moving like that, all of them in the same plane. Okay. It is not like the sun is here, one is moving like this, and they are moving like that. No, that is not true. Okay. So, that was a clue. And then the distances to the planets also has an order called the Bode's law. I will not go and get into the details of it, but it is also it has a the distance from the sun to the planets also follows some kind of a law, empirical observed law, but nevertheless it is not just any position of the planets. And thirdly, people had observed that the sun is actually rotating body, and therefore it has a angular momentum. The planets are also rotating around the sun, therefore they also have angular momentum. And when these angular momenta were measured, people found that the angular momentum of the sun, a huge body, is very low, about 0.5% of the total angular momentum of the solar system. And the larger chunk of the angular momentum are carried by the 4 giant planets in the outer periphery, Jupiter, Saturn, Uranus, Neptune. So, the clue regarding the distribution of angular momentum. So, such facts were known about the solar system when people started trying to explain why, trying to guess how this solar system came into existence. And the first shot came by a French naturalist, Georges Buffon. His timing was 1707 to he pictured that at some point of time the sun was a isolated body without any planetary system around it, and he pictured that some comet came and hit the sun, and in that time it was not known what comets are made of. They look big, and therefore he believed that it is a big object, and it came and hit the sun. And when let me delete this and draw it here. So, there was a sun like this, and it is hit by something. So, it a few droplets will spill out of this, and these droplets ultimately condensed into the form of the planets. That was his hypothesis. Notice that this hypothesis actually satisfies all the requirements that we have stated. The falsifiability requirement, I will come to that later. After some time, it was found that the comets are very small objects. They look big because that is diffuse. They produces a long tail of very dispersed gaseous substance, but it's not, it's the mass of a planet is not substantial to do what Buffon actually pictured doing. So, in that situation, these two scientists, James Jeans and Harold Jeffreys, Jeans and Jeffreys, they propose that no, might be that the body which actually caused this was not a comet, but suppose the sun at some point of time was a isolated body without a planetary system, but another star passes nearby. What will happen? Because of the tidal action, because of the attraction of that other body, there would be a bulge created, and at some point of time some parts will be torn off from the body of the sun, and as this fellow moves away, these will keep on rotating around the sun, and after some time they will condense into the planets. This is also another hypothesis which are consistent with the clues and satisfy all the requirements of being a scientific hypothesis. These kind of hypotheses were called the catastrophic theories. I would rather call it hypothesis. Catastrophic means the creation of the planetary system is caused by some event a catastrophe, something happened like the collision with something or a nearby star passing close by, so that it tears off a part of the sun, something catastrophic. While the philosopher Immanuel Kant, we have met him earlier in the classes on causality and other things. So, Immanuel Kant, he is the person who pictured that everything in the material world are in a state of flux, in a state of change, evolution, and therefore, he also pictured the solar system having been created through a process of evolution. How? He said that before even the sun was there, in that position there was a diffuse nebula. So, if I draw it here, there was a diffused nebula, say over this range there was a diffused nebula. Nebula means it is a dispersed cloud of gas and dust, but this nebular cloud will have its own gravity, and so by the action of that gravity it started to condense. So, it would condense and collapse. It is called gravitational collapse. And as it condensed and collapsed, the potential energy of the particles will be lost, and that potential energy would be converted into kinetic energy of the particles, and thereby the temperature of that gas will rise. And as it condensed, in his time the fact of thermonuclear fusion was not known. So, he pictured that it will become hot, and ultimately this collapsing process will produce the star at the center. But while this was happening, if this initial mass of nebula has a slight bit of angular momentum, then as it condenses, the angular momentum will make it, angular momentum will conserve, and the conservation of angular momentum will make it spin faster. And if it spin faster, it will become something like a disk. So, it will not be exactly like that, it will become a disk like thing. Something like this. I would picture it like this. Like this. The central part, central bulge, that is what produces the sun, and the disk like part where there is an extended part, disk, in that the planets form by condensation. That was Immanuel Kant's theory. This theory was supported by many scientists, including Laplace. So, when Laplace took up this particular idea, he was a great man in classical mechanics. He calculated and showed that this disk, it will not remain a single disk, but it will become composed of rings of gas and dust, and each ring would condense into one planet, and that is why the planets are there at different distances. So, it is not just a uniform mass in the disk, but there will be it will look like rings, like the Saturn's rings, and the planets will form in these parts. It will go around, it will be rotating, and as the rotation happens through collision between particles, this will happen. So, these two competing hypotheses was called evolutionary hypothesis. Notice that both these hypotheses are scientific. It does not, scientificity does not depend on whether ultimately it proves to be true or not. Both these hypotheses are scientific. They are based on material processes and phenomena. They satisfy the initial clues and so on and so forth. But when James Clerk Maxwell, the same Maxwell of Maxwell's distribution or Maxwell's laws of electromagnetism, same Maxwell, when he argued that the sun and the planets after all formed from a mass of gas and dust that is distributed over a range something like this, that was initially distributed over a range something like this. So, today whatever is the mass of the sun and the mass of the planets put together, that must have been at some point of time distributed over this range, and that suppose that is a sphere. So, how much will be the density of that sphere? When he calculated that density, he found that it is so low that that would be insufficient to cause any gravitational collapse. So, sun cannot form out of that kind of a process. Because Maxwell showed that for a great stretch of time, the evolutionary hypothesis was actually abundant and the catastrophic hypothesis was actually supported by people. Then in the 1920s, a German scientist Weizsäcker, he hypothesized that the initial mass of the nebula was much larger than the mass of the solar system today, about 100 times larger. So, that would be sufficient to cause the collapse, and then he said that when the sun starts burning, it emits what is known as the solar wind, and that is what ultimately pushes the large mass of gas from the periphery, and that will be lost into the neighboring areas, only leaving the planets bare. So, ultimately it will settle to a size, settle to a mass which is about 1/100 of the initial mass of the nebula. When that hypothesis was proposed, again the evolutionary hypothesis came into light. That means, both these became competing hypotheses. Now, notice each hypothesis should have experimentally testable prediction. So, what can be the experimentally testable prediction? The people who proposed the hypothesis, at that time this methodology was not all that much developed. So, they themselves did not propose the experimentally testable prediction, but other people did. Other people started from that premise, and by logical derivation they argued certain things. For example, it was known that hydrogen and deuterium are two isotopes, hydrogen and deuterium, H and D. Deuterium is very stable substance, deuterium is very stable substance, and it does not break up so easily unless it is subjected to great heat, like at the center of the sun. When it takes part in thermonuclear reaction, then it can no longer remain deuterium. So, if this is when this was learned, then the implication for this catastrophic and evolutionary hypothesis was that, notice the questions were A, were the sun and the planets cogenetic, that means they were born through the same process, or the sun was earlier and the planets were later. Two possibilities. Again, were the material that form the planets today ever heated in the temperature of the sun? Because if they were a part of the sun and they were torn off from the sun, then that material was a part of the sun earlier. Well, now the logic was that if deuterium is a very stable substance, unless subjected to the heat as in the body of the sun, then if the material that is now forming the planets was ever a part of the sun, then definitely the deuterium to hydrogen ratio would be different in the sun and in the planets. If the planets never were a part of the solar body, then the D to H ratio, so they were talking about the D to H ratio, this ratio will be this ratio will be different, while if these bodies, the planets, were at some point of time a part of the sun, then the D to H ratio would be the same. And then people went on to actually measure the D to H ratio in the sun and in the planets. One planets we already have, there is a Earth, we could easily measure that, and when people measured that, they found that these are different by 2 orders of magnitude, which means that immediately proved wrong those theories that said, those hypotheses that said that the planetary material was at some point of time a part of the sun. Those theories are definitely wrong, and therefore, people homed on to, or they had larger trust on the evolutionary hypothesis, which is now accepted to be the correct explanation of the solar system. In the meantime, other hypotheses were also proposed. For example, some people proposed that it is a catastrophic theory, but the body that came close to the sun was not a full-fledged star, but it was a protostar before the thermonuclear reaction started, and therefore, when the body actually passes, the tidal action will tear off drops, but they might not be from the sun, but from the other body, and all those kind of theories were there. Notice that people were at that time proposing many possible hypotheses that are consistent with the clues, but ultimately the test came in the form of checking whether the material of the planets was at some point of time in the sun or not. And when that test came, people realized that okay, the catastrophic hypothesis cannot stand any longer, and we have to home on to the evolutionary hypothesis. And within the evolutionary hypothesis also there are some variants, different hypotheses, and we are now working towards eliminating the wrong ones and homing on to the correct one. For example, the reason for this, the distribution of angular momentum, that is still a point of argument and debate, what actually caused the specific distribution of angular momentum. People are trying to work on that. People are again proposing hypotheses and testing, and the wrong ones are being eliminated to find out which one is correct. This is how science works.